Hello everyone. So myself, Dr. A H Srinivasa, working as a professor and head in the Department of Mathematics. So you know that mathematics it should be deals with the shape of logics and arrangements and also qualities. So whenever you enter to the engineering branch, you should have to learn the mathematics for 2 years. That means you have to learn the mathematics up to 4 semesters. After the 4th semester, the electives will be offered to you. If you're interested, you can take the mathematics also. Okay. In this lecture, so we are going to concentrate on first semester engineering mathematics subject, that is calculus and linear algebra. The subject code for that one is 18MAT11. Okay. The syllabus for this, it containing totally 5 modules. In that 5 modules, I will take a first module, that is polar curves. Okay. The polar curves having 5 chapters. In these polar curves, in the first we are learn the angle between radius vector and the tangent and the related problems. In the second chapter, we learn pedal equation and related problems. In the third chapter, it is the radius of curvature and related problems. Here, they particularly mention the problem should be able to solve only for Cartesian as well as polar curves. In the fourth chapter, we learn center of curvature and circle of curvature. In the last chapter, it is an application oriented problem, that is an evaluate and inevaluate. These are the 5 topics we are studying in module 1, that is polar curves. Okay. The major application of polar curves we are used to detect the sound waves. We are going to only see the 2 direction paths, that is an x and y axis, that is an horizontal and vertical distances in case of Cartesian curve. So whenever if you go to learn in the polar coordinates, we are going to find out the exact, that is an absolute path, so which are an absolute distance from this certain point. The polar curves are the describe a directional microphone pickup pattern. And also we are use polar coordinates to determine the exact audio pickup pattern for cardio microphones. And also we are use polar coordinates in day-to-day life with having a calculation for involving aircraft, navigation, gravitational fields and radio antennas, in addition applications in which polar coordinates are used. The polar coordinates having a better mechanism and understanding on electricity and also magnetism. So these are the major applications we have seen in the polar curves. Okay. First let me understand what is polar coordinates. So everyone knew that what is the Cartesian coordinates. In a plane, if containing this is a vertical line, this is a horizontal line. This is called as an x-axis and this is called as an y-axis. So this is we called as an Cartesian coordinates. If coordinates containing x and y, we call as a Cartesian coordinates. Okay. So in this Cartesian coordinates, we have to only see a 2 path. If using that path, we can make it as here we are going to find out the distance only in x and y direction, only 2 directions we are going. So particular path we are seeing only 2 directions. Suppose I wanted the entire 360 direction path we needed, in that case we can use a polar curves. Okay. If you make a polar coordinates, if you mark a point, that is a P of x comma y, if you join origin and draw a perpendicular line, this we call as an M. Okay. From this you can call as an origin, that is in an Cartesian coordinates, the distance is x and where distance is y. Okay. If I make an angle of theta, then how to make a polar coordinates? By using your Cartesian coordinates. So it just is exactly in the form of a right angle triangle. So using a right angle triangle, OMP, this is an exactly 90 degree. And the length of OP we can call as an R, a distance. So whenever in the polar coordinate, this place we call as a pole, the origin we call as a pole. You have to remember, the origin we call as a pole. So this is for Cartesian coordinates, we call as an origin. In the polar coordinates, we call as a pole. Okay. The distance OP, here OP is the distance R. In the polar coordinates, we call as a radius vector. This is a radius vector. Okay. And your x-axis in Cartesian coordinates, whenever we say in the polar coordinate, this is called as an initial line. So your OM equal to x called as an initial line. Okay. So you have to remember this in case of polar coordinates. This is the notations we are used. Okay. So then after that, using this right angle triangle, we are making two polar coordinates. Okay. In a right angle triangle, OMP. So what about I wanted to sin theta? In a right angle triangle OMP, I wanted to sin theta. We know that sin theta is an opposite by hypotenuse. You are opposite by hypotenuse. What is your opposite? It is an y by r. We make a cross multiplication. We get y equal to r into sin theta. We get one of the coordinate value y. We get there is y equal to r sin theta. In the same way, we can also find out the other coordinates. I wanted to find out the value of x. So for that, we can take a cos theta. For this right angle triangle, we can take a cos theta. What it gives, cos theta is, it's an adjacent by hypotenuse. What is an adjacent value? Is an x by r, your hypotenuse. It is an OP. Then I wanted x is r into cos theta. Now your Cartesian coordinates x comma y changes in terms of what? Your x comma y, it will be changed to r cos theta, then r into sin theta. So this is the polar coordinates. I am going to representation of polar coordinates is containing r as well as theta. It's clear? Okay. So after learning these, now we will move to the syllabus top part. It is a first topic. It is an angle between radius vector and the subject as a calculus and linear algebra. So I will take a module 1. So that is first topic is polar curves. In that polar curves, the first topic is angle between radius vector and the tangent. In your examination, directly they ask find the angle between radius vector and the tangent, or sometimes they are asked in the form of notation. Prove with usual notations like that. First done. Prove with usual notations tan phi equal to r into d theta by dr. This is the one format, the angle between radius vector and the tangent. The another format is there. If you take the reciprocal of this over r, you can also say something cot phi equal to, it is an 1 by r dr by d theta. If you take the reciprocal of this, we get obtain of this one also. This is another format. In the statement form, they ask find the angle of intersection between two curves, or sometimes they ask directly prove with usual notation like this. Okay. So this is the proof. This is our Cartesian curve, So make it as polar coordinates. Now I can take a curve. This is our polar curve. We call it as an r equal to f of theta. For a Cartesian curve, we taken y equal to f of x. Instead of that, we are taking r equal to f of theta is a polar curve. And I mark a point p of x comma y. And draw a radius vector. This is O is a pole. This is P. And draw a tangent. This is the tangent. We call as an M. Here some angle we call as an theta. Here one more angle will be obtained, that is called as psi. Here we call as a phi, and here also phi, because vertically opposite angle. And the distance from O to P we call as an r. Okay, this is called a radius vector. A simple construction is there now after writing this figure. Let r equal to f of theta be a polar curve. Let r equal to f of theta be a polar curve. In that polar curve, you mark one of the point p of x comma y be any point on the plane. P of x comma y be any point on the plane. Okay. Then theta. Now theta is the angle between. This is called radius vector. We call it as an OP equal to r, called radius vector. Radius vector. And OM is the initial line. OM, simply called as an x distance like that, called initial line. Initial line. So you are using initial line, tangent and radius vector. Three types of angle will be developed. One of the angle is theta. So this is the theta, the angle developed between the radius vector and the initial line. And phi is the angle is developed by radius vector and a tangent. So phi is also an angle developed by a tangent and a initial line. So that one you can write down here. Theta is the angle between radius vector and tangent. Then phi is the angle between radius vector and tangent. So this is not a tangent. Theta is the angle between radius vector and initial line. Phi is the angle between radius vector and the tangent. Then psi is the angle between tangent and the initial line. Okay. So this is the construction you have to write on that. Let me explain again. For a polar curve r equal to f of theta, this is your polar curve. In that polar curve, you make a one point, that is p of x comma y. Then you call this as OP equal to r, called a radius vector. And OM is an initial line. And theta is the angle between radius vector and the initial line. So theta is the angle between radius vector and this is the initial line. And phi is the angle between radius vector and the tangent. And phi is the angle between tangent and a initial line. Okay, this is the simple construction. So we know that your exterior angle is equal to sum of the interior angle. So that means psi should be equal to, this is your exterior angle, it should be equal to sum of the interior angle. We know that we know that exterior angle is equal to interior angle. So that is psi equal to phi plus theta. So this is the notation I have to remember. Okay. Then after that, we know that the slope of the tangent. What is the slope of the tangent? It's a derivative. Now, slope of the tangent is dy by dx should be equal to tan psi. Okay. Now, just you write down in place of psi, phi plus theta. Okay. That is your dy by dx equal to tan of phi plus theta. Now it is exactly in the form of tan A plus B formula. You have to use the tan A plus B formula, that is tan A plus tan B divided by 1 minus tan A into tan B. That is dy by dx equal to tan phi plus tan theta, then all divided by 1 minus tan phi into tan theta. Now call this as an equation number 1. You can call this as equation number 1. Okay. So now we are going to, one stage will be over. So now I'm going to find out the second stage. That means we are going to conversion of Cartesian coordinate to polar coordinates. Okay. So now I'm going to convert Cartesian to polar coordinates by taking a substitution. X equal to r cos theta and y equal to r sin theta. So first we take a x equal to r cos theta. Now differentiate this with respect to theta. Now we get dx by d theta. I'm going to differentiate this one with respect to theta. The first into second minus theta plus second into first cos theta into dr by d theta. Okay. In the same way, we can do the other function also, y equal to r sin theta. Now differentiate with respect to theta. That is dy by d theta. First into second plus second into first. So now both are in Cartesian form is there. Now I wanted to dy by dx. So we know that dy by dx, it is a parametric form is there now. So that is dy by d theta, then all divided by dx by d theta. It is a parametric form is there now. Now I'm going to substitute the respective terms. That is dy by d theta is r cos theta plus sin theta, then dr by d theta. Here, so I am interchanging and writing this one. Cos theta into dr by d theta minus r into sin theta. So like one of the term as a common, that is an cos theta dr by d theta. Now take a term as common factor or divide the entire both numerator and denominator by cos theta into dr by d theta. So now check what we get now. Now divide by cos theta into dr by d theta, both numerator and denominator. Now check it what happens we get now here now. Now our dy by dx, it should be equal to, if we are going to divide by this, if we go to division of this, both cos will be cancelled. We get r divided by dr into d theta. Or simply r d theta by dr. If we divide this one, if we divide here, cos theta will be cancelled. If we take a reciprocal, then r into d theta by dr. Then plus If you go to division of this one, sin theta by cos theta, it is a tan theta, and both dr by d theta will be cancelled. You get only tan theta. All divided by, then 1 minus of, these two terms are cancelled here. We get 1. Then again the same procedure is there now here. R into d theta by dr into tan theta. Now call this as an equation number 2. Now compare equation 1 and 2. What do we get now here? Compare equation 1 and equation 2. Now check it what we get now here. If a comparison in equation 1 and 2, just you have to watch in the place of tan phi in equation 1. Both LHS are same, both LHS having a dy by dx. In the RHS, tan theta place, same thing is there now. Only the thing will be changed here, tan phi. From equation 1 and 2, we simply write down tan phi is r into d theta by dr. So this is the proof we needed here. So this is called the angle between radius vector and the tangent. So one case will be proved. Sometimes if you want this result in terms of cot, what do we get now here? If we take the reciprocal of this, taking reciprocal, what do you get? Reciprocal of tan, it becomes a cot. If we take the reciprocal of this, 1 by r becomes 1 by r. This is become dr by dt. This is also called another form, the angle between radius vector and the tangent. So this is the proof you have to remember, the angle between radius vector and the tangent. Intersection between two curves. The angle of intersection between two curves. This is the second topic. This is a continuation of that one. The angle of an intersection between radius vector and the tangent. So what happens if two curves are present in a plane? So that will be result will be obtained now here. So this is your one curve, and one more curve is there now. Both curve having a same tangent. And the radius vector is there now, O. This is P. As usual, this is psi, and this is theta. So here 2 phi 1 will be up here. This is called phi 1, and one more is in phi 2, and this is we call as in phi 2. Here an angle will be obtained now here, that is called as in phi 2. So generally we can write down directly the result of angle of intersection between two curves. Simply we are taking as an tan phi 1 minus phi 2. The result for this, tan of phi 1 minus tan of phi 2, then all divided by 1 plus tan of phi 1 into tan of phi 2. So this is the result we are used to solve some more problems to extract the angle of intersection between two curves.